Okay, so we do have the link for the collabs. I have good news.
Good.
Okay, so if you go to github.com/Princeton School of AI, you're going to end up here. If you scroll down, you're going to see this M101 11 2019. Then you click here, and right here you're going to have second class. You want it to go again? Okay, so github.com.
Yes.
Very good.
Yes.
Now you click here, Princeton. That's Princeton School of AI at the search. Let's put all together. Okay, so if you put Princeton School of AI all together at the search bar, all together. Then you click at users. You're going to have Princeton School of AI. Another way of doing that is github.com/Princeton School of AI. All together. Scroll down. You're going to see M101 11 2019. Is everybody on the same page, or is someone behind? Click here. You're going to enter the Machine Learning 101 from November, 2019 November. If you scroll down, first class, the Google Colab link. The second class, click at the second class.
Must be help. Looks like it's help. Yeah, yeah.
I can put mine.
Yeah, a lot of people in the application data. Oh, yeah. Okay. Yeah.
All right, so is everybody here at the Google Colab? Okay, now you click File. Then put Save a Copy in Drive. Once you do that, you log into your Google account, and then you're going to have your own copy that you can work with. You can change, you can modify, you can do everything. And if it stops running, you just come back to the original one that's going to work. Okay?
You wanted to save a copy in Drive, not any of the other choices, right?
Sorry?
Save a copy in Drive.
In Drive,
Right.
yes. And it's going to ask for your Google account.
Right, yeah.
And this is going to be in your Google Drive. You just go there, click, and
Okay.
The thing that we like to create here at the School of AI is to create those Google Drives, those files that you're going to have in your own account, and you can simply access whenever you want.
Mm-hmm.
That's this is
Sure.
I think it's good. You said click locate and draw.
sorry.
So you said click locate and draw.
No, click file, save a copy in Drive.
Okay.
So you can look at that site and download on the.
Basically, if you just enter this site, you're going to have all the code. And if you save a copy in Drive, you're going to have your own version of it that you can change. This I blocked, so it cannot be modified. I hope. Because we had issues with that before. But let's see, so who here wasn't in the first class?
Yeah.
Okay, so a lot of people. The first class we just went through some descriptive statistics, and today we're going to start with the machine learning part per se.
You know,
Now,
I just say.
a lot of money. I think it's I think Warren's going to run into a lot of trouble.
okay, guys, just a second here. Do you need help?
She is. But I just think that
Okay, let's see. Right. So last class we agreed on use on have one database for this for today. Let me see what we have in mind. So I'm grabbing here the what we discussed.
you're like,
Right. So on the 12th, which is today, we're going to talk about healthcare. So basically, we had a voting, and we decided which topics would be assessed in every single class. So on the 12th is healthcare. We're going to do that. The 19th is going to be finance, and then on the 26th, it's going to be recommendation systems. On target advertising. Okay. And regarding models, we're going to go through today on let me close this because I talk very loud. So we're going to go through the decision trees and random forest. So that's today. Next class, we're going to go through random forest and then XGBoost, which is simply fantastic. And finally, we're going to, the last class for recommendation systems, we're going to go through K-means and KNN, which are clustering algorithms. Who here thought that I was talking Greek? Okay. Let's change that. Let's see if after this class we're going to have something good. Again, and not only this, but last class was a little bit tiresome. I don't know if you felt that. Usually you can feel the class. You can feel if people are engaging, they are interested on the topic. And as it was data, it's so boring. And I was wondering what we could do differently. And maybe, so I'm going to try something different that I haven't tried before on these classes. We've been teaching those classes since March. And we're going to live code it, everything. Together. That's why you have your own notebook. I have mine. We're going to code together because maybe this is going to, you're going to have a hard time trying to run something, but usually the problem is with spelling. So that's there. You're going to see a lot of mistakes happening here, a lot of error messages. We're going to copy paste that into Google. We're going to figure out what's wrong, and you're going to see how I usually work. It's not like this happens, there's a joke. Which tool is the most important tool for a data scientist? Which tool is the most important tool for a data scientist?
Tab completion.
Tab completion.
Tab completion.
Tab completion is very good. That's true.
Copy
SQL.
paste.
But I don't agree, and I don't agree.
Copy paste.
Google.
Oh, okay.
Basically, you spend your whole day at Google. You run one line, a few lines, and something goes wrong. You copy paste that in Google, and you figure out what's wrong with that.
Stack Overflow.
Okay.
And
And
those specific. Stack Overflow.
so let's see if this is going to be this is going to work. If not, we simply go back to the way that we used to do. All right. Okay, so let me see. Do I have some announcements? No, I don't think so. I believe that computer is free. For those who arrived a little bit late, on GitHub, you're going to have, so Christian School of AI GitHub, github.com/Christian School of AI. Scroll down, you're going to have the machine learning 101. And at the bottom, you're going to have the second class. Google Colab. Questions?
About the deep learning, then.
Deep learning?
Yeah.
Why deep learning?
That's probably 102.
No, deep learning is 102. That's not far. So today we're going to discuss a lot how machine learns. The goal of today's class is, at the end, you're going to understand how machine learns. That's it. We're going to look into one algorithm called decision tree, which is one of the most important algorithms. Nobody uses it, but it's very good for visualization. Whenever you're doing something, and look, in your daily life, you work in a company, you have a company, etc. You have to showcase, you have to pitch your idea, you have to pitch your results so you can get the things that you want to do accepted by the others. Whenever we run a deep learning algorithm, nobody knows what's happening behind it. It's a crazy thing. So you need something that you can actually visualize and show and say, look, the idea is this. So decision tree is going to help you with this a lot. That's the idea, but I've used deep learning, which does something similar, which is not, but to say that it is something similar and has a much better result. So today we're going to see this decision tree. That's I would say that this would be the second algorithm that you learn. The first one is linear regression. And probably is as important or even more important than linear regression, I would say. That's it. And then we're going to go to random forest. We have a decision tree. Random forest is a bunch of trees. That's a forest. So, and then you have some voting system to see what is the final result. But I'm going to get there later. What else? Questions? No? Okay, so last class, and thank you very much. You sent me one database, correct? Yes. So last class we voted for a healthcare problem. And the problem that was raised here, the problem that was raised here is that you have some codes, some healthcare codes, that is misused or intentionally or not intentionally by doctors or insurance providers, etc., and you have some fraud over there. You have some losses. Let's put that way. And then I was sent a database to work with, which was actually very good. but the database only had the information regarding the codes. So there wasn't much to do with algorithms unless we would build some sort of a search engine. So you describe like a black eye, for example, and this would output the number that you should input for the insurance purpose. But this we would have to deal with natural language processing, so it's not 101. It's not 101. So what I decided is to find another database that also deals with fraud insurance that we could work with and see if we can find some interesting relation on that. The database is very good. It's very good. I like that a lot. And I was even thinking about having the other classes only dealing with this database because it's very rich. If I'm going to
Where's it from? From CAG?
Kaggle. Yeah, so I'm going to say 2 or 3 things that I said in the previous class, but it is very important. 1, Kaggle. It's a very good website for you to find databases and business problems. If you have one business problem that you want to tackle and you want to find some solution or some assessments or databases, Kaggle. Go first here, put the keywords that you want to assess, and they're going to output some pretty good databases or cases. We are at Kaggle. I'm not going to make the whole presentation that I did. Kaggle. So whenever you type this, you're going to search. Everything knows what's going to search. I have some models here. Always you're going to type something and probably something is going to come up. And you can start looking at that case. Now, the first thing about data science, what is? Solve a problem. We have a database here. Let me show you. That's Kaggle's website showing the database. So, sorry. I'm going to go back here. So we have 4 main databases. The first one is inpatient data. So the patient that entered a certain facility and was accepted. So he had a complaint, and this was accepted to be treated. Please. Thank you. So we do have a lot of information regarding this process of being accepted. So we have the ID of the person, the claim ID, when this claim started, when the claim ended, the provider, how much was reimbursed, the physician that first attended, if it was operated or not, or other physician that was treated. We have admission date, the diagnostic code, deductible, amount paid, discharge date, so that's when it enters and that's when the person left. And you have some diagnostic group and codes. You have some codes of diagnostics. A lot of those, I think. And also the procedures as well. Okay? Guys, cool. Yes?
Yes.
Right. So a person entered the hospital and said, look, I feel this, and it's going to be attended by a doctor. This doctor is going to accept this person. So this database is only for those who are inpatient. We're going to have the the others that weren't accepted. We're not going to use that right now. And we have the whole treatment that this person went through. Okay? That's this database. Now we're going to have another database. Imagine that if you have Excel spreadsheets, you have the first spreadsheet, was that one. Now we are going to the second spreadsheet. That is the patients. So the data providers detail the claims field for those patients who visit the hospital and not admitted in it. So those guys weren't admitted in it. So we're going to have a bunch of MAs here. For this first version of this class, we're not going to use this database. We're just going to use the database that person who were accepted. Okay. And finally, okay, the third one is beneficiary details. Now we're going to have information about the person that entered the hospital, that were admitted at the hospital. They have gender, race, state, county, and some health information. Chronic condition, heart failure. And finally, look at this. Yes,
It's real data.
real data,
It's not fake.
not fake data, real data. Let me just do something here because we are live coding. Okay, that's the fourth one. Okay, yes. So here at this cell, please change to data label, data underscore label.
Okay, that's nice.
So we had here data beneficiary data.have. And right below here, we're going to change to data underscore label. By the way, you have to run every single cell before that. So let's all together go. Let's do that. Run the first cell. You can run the first cell by pressing the play button or pressing. Oh, what is the Shift Enter? See if Shift Enter Mac accepts Shift Enter. Yeah, so Shift Enter or play. As a data scientist, please press Shift Enter. Do not click on play. So that thing to use the mouse. And finally, we have data label. Yes, question. Okay, that's a very good question. Let me just finish the landscape, and then we go back to the first cell, and I'm going to go through the code that you have. Now, who here thinks that this is a very good database to have? The last one, the last database that I have on site is data label. Data label has a provider and a label of rotation front. So that's fantastic for us. Because we have labeled data. We have data that we're going to train an algorithm to learn the patterns. We have the output to train. So that's the machine learning. How the machine learns? It has some information that it's going to use to capture the patterns of the data and that outcome to see if it can make the prediction of that outcome. So we have 4 data sets here. The problems with the patient, when this patient enters the facility, the characteristics of this patient. We have the database of the patients that were not admitted in. And finally, we have labeled information if that transaction is fraudulent or not. This is the dream for the scientist. This is what we always want. A lot of information and an indication if it's, in this case, it's fraud or not. Because we are going to try to grab the patterns that are going to showcase the fraudulent cases and the ones that are not.
You said the pattern.
The patterns. That's the key word here. The key word for machine learning algorithm are patterns. This is very important. The algorithms, they don't capture every single case. Algorithms capture patterns. Models capture patterns. If a certain pattern repeats and it was labeled as fraudulent before, he's going to output. There's a very high chance that this is a fraudulent case. Okay? I have I'm doing another presentation on how to put AI into your company. And the first slide that I have is what is the difference between AI and machine learning and how AI was before and how it is now. So before, AI was every single system that by itself would recognize the situation and make a response to that situation. So this is the definition of artificial intelligence. Artificial intelligence is every single system that, whenever it looks into a situation, is aware of what's happening and takes some action by itself, without having anyone to help the machine. What is the simplest case that I could think of, not to artificial intelligence, using this definition? A door. So here, this door, I have to open it. If there's a person outside, I open it, this person enters, and I close it. The door closes itself, which is good, but it doesn't open itself. It doesn't recognize the situation and make a decision on it. Now, automatic doors, they are like this. You arrive there, they recognize the situation, they open, you enter, they close it. So this would be the simplest artificial intelligence that I can think of. Now, this is a rule-based artificial intelligence. What this means, they have a picture of when there's no one trying to enter the door. And if that picture changes, it opens. There's a rule there. What is the best AI that is rule-based? Deep Blue. IBM Deep Blue. Who here remembers IBM Deep Blue?
I saw it in action.
Yeah?
I saw it beat Kasparov.
Really?
Yeah. In Philadelphia.
So this AI algorithm actually beat Kasparov in chess. So that's the first computer that beat human being, the world champion human being. Now, it was able to make predictions. So he would look into the chess board and evaluate every single possibility, 10 rounds ahead, and make the best decision. So you can imagine that an algorithm like that, it needs a lot of memory, a lot of processing power to capture all the millions. I think it's 200 million possibilities that every single round it went through. Now, 2016, AlphaGo won the Go game. Who here heard about Go? Okay, so Go is the Chinese version of chess. And 2016, I think it was 2016, AlphaGo won the champion. I don't know if it was Chinese or not. The machine won. But Go board is much larger, and it wouldn't be impossible for a rule-based system to make all the calculations itself. How did it do it? Using machine learning. So machine learning is something that is embedded into an artificial intelligence. It's something that is going to make the decision group of what to do. And then the system is going to act on that. So you're going to have solutions that you're going to put out there. There are machine learning solutions. There are others that are going to be artificial intelligence. If the system uses the machine learning solution to make a decision and act, that's artificial intelligence. Now, why I did all this? So I said all these things to come back to the point where nowadays artificial intelligence, as we are discussing here, grabs patterns. Machine learning grabs patterns. This means that it's going to make mistakes, but most of the time it's going to nail the correct decision. It's going to find the correct decision. So it's a probability based. That's what we are doing here. Questions or comments?
Can it take steps to find its own mistakes?
To find its own?
It makes mistakes, you say.
Yes.
Can it correct the mistakes?
Yes, and that's how the machine learns. I'm going to show you how. So, but before that, let's go back to the first cell. All right. So I'm going to go through every single cell and every single line of code so everybody understands what's written here and can replicate at home. The first line is import pandas as PD. First, how Python works, we're going to use packages from that other people developed. So you can leverage on those. Pandas is the Excel, Python's Excel. Every single time you're going to use pandas, or most of the time you're going to use pandas. And I put SPD so I don't have to write pandas every single time. I just write PT. You're going to see below that pt.read something. All right. Matplotlib, this is a package to plot things. sklearn, you see a lot of sklearn. Now this is the main guy here at Python, because this is the package where you're going to have all the machine learning algorithms that you're going to need. Not only algorithms, but also other classes, other things, other objects that are going to help you do machine learning. In this case, we are importing here a standard scalar, min-max scalar, which is basically whenever you normalize something, we're going to use this. Train test split, I'm going to explain this later. And of course, decision tree classifier and random forest classifier. Finally, datetime, I'm going to use that later. Usually datetime is whenever you have some type of data, different type of data. And one of this type of data is timestamps. And datetime is one of the packages that Python uses for timestamps. Now, what are these? Everything here, I'm reading a CSV. So basically, what this does is pandas PD dot read CSV. So pandas is saying, look, yes.
What's the percent sign before matplotlib?
That's a very good question as well. For the percent, this guy here, usually this display of Python is called a notebook. And for notebooks, I don't know if Google Colab has this problem, but usually Jupyter Notebooks has. And we put this so the plots can be shown not in an external page. So whenever you put plt.show to show the chart, it generates a pop-up that has the chart. I don't want that. I want that to be applied here. Right. So coming back, databases. So this cell here, we're going to read every single database. So I have first data label. Now you see that this is a link, correct? Yes. Thank you. If you copy that, in the case here, it's up here. So what Pele is doing is he's going inside this link. I haven't parsed any parameter here. I could have done this. Comma set equals semicolon. Whenever I do this, pandas, whenever it's reading a given CSV file, if it is tab separated, you put this right here. The default option is comma separated. So if you see here, you're going to have columns. You have comma separated. So it's going to understand that it has two columns. So let me here. Well, this is the output. I just asked for the head, just asked for the first 5 rows. And that's the output. So you see it looks much better, right? Wider, and also it reads. And if you try to paste all the others, you're going to find a similar situation, but with more columns. And this pg.read CSV, it's that. Okay? Right. Questions?
What are the full files?
I'm sorry?
You said 0, 0, 3, right? There's 4 files.
Yes. Well, I have a problem with this file. Remember that I cut everything from this Kaggle, so it has this train and test data sets. And this data set, this one, was particularly big. Not big, 73 megabytes, which is not big at all. But in GitHub, you can see that this is a GitHub link for Princeton School of AI. That's the same thing that you're seeing. Basically, you're seeing how I set this, how I put together this. Those are the CSVs that the PT is looking into. And at GitHub, they only accept files of at most 25 megabytes. So I had to break down that CSV into 4, I think, yeah, 4 CSVs. So that's why we have data, outpatient data, 0, 1, 2, 3, and then what I do here, I put everyone together. Like this. So you can see that the data 0 dot shape, the shape of the database has 135,000 rows, and the combined one has 517 rows. Okay, that was the reason that I split. Moving forward, whenever I do head, it shows the first 5 rows. If I want to see a little bit more, I just put the number, and it's going to output the number of rows that I asked. So we have gone through the databases. Now, whenever I do dot columns, it shows every single column of a given data set, a given database. So far, okay? Questions, comments on the coding part? No?
Good.
All right. The last one? Columns. Here, the point here, what I did here was the point. I have too many columns. And when I look into the columns, that's clear beneficiary. When you look into the columns, you're going to find some columns that are not going to be important, at least at first. Oh, by the way, a very important thing. Whenever you get a data science job, you have to build a model. Deploy the first one as fast as possible. Get rid of columns that is going to take some time. Basically, deploy the first ugly version of the model. And then you're going to move on building a better model. So what I did here was, I have a lot of
Make a
columns.
list.
But basically, the last one, I'm going to have a lot of names. So, CLM diagnostic code number 9, number 8. What I thought, well, we do have a group. We have number 1, number 2, number 3, number 4, number 5. I have a lot of them. So I'm going to get rid of some of those. So I'm just going to maintain a few. I think I maintain just the groups, number 1 and number 2. And later, I'm going to see how those codes can help me predict something. That's why what I did here was to check every single column that this database has. And you can see here that I started to build my final data sets. How I did that? So remember that I have 4 different data sets. I have the characteristics of the patients. That's data B. I have the characteristics of the problems that that patient presented at this claim to have, and I have the whole treatment. This is data, inpatient data. I have a third database that I'm not going to use here. Okay? That is data patient. And finally, I have the labels. If this guy here is fraudulent or not. The provider is fraudulent or not. But they are separate. What I want to do is to join them into one single data set. That's what I'm going to do, and that's where we're going to start the class. Okay? Yes.
Not in order. Like it's not just like something adding the kind of match.
It is. It is some sort of an Excel, SQL thing. That's why I'm going to use merge.
Oh yeah, like so they're in order. Like you don't have to like move it.
No, I do, because they're not in order. Now, and every database they have different keys to relate from one another. So let's go there. The database I'm going to call data. That's my final database, and I'm going to start saying, look, I'm going to get from this data application data. I'm going to get only these columns here instead of all the columns. We're going to get a few of those. So admission DT, I deleted that. Discharge DT. Attending physician is here, but operating physician and other physician I deleted as well. And after CLM diagnostic code 2, I deleted everything. But I had a to have this. So it's as simple as doing this. Yeah. So, whatever, whenever I do this, basically, now I have a new data set of data that has only the columns that I decided to have. Not all the columns from the patient. Okay?
So add two more.
Just like,
Yes, I did.
Oh, yeah.
I did. So I added from the original code that you have, I added those guys here.
and then the next thing.
Simply copy and paste.
I think you need, because you may not need it.
It's not going to make a lot of difference, don't worry. It's not going to be important now. Remember, what we're trying to do here is to output the ugly version of the model. And then it's all a matter of working with this data, working with every single column, assessing every single column. I have a lot of work to do here. Usually, in a data scientist life, 80% of the time is working with the raw data sets instead of the machine learning algorithms themselves. You're going to see that to train and to make a prediction of a machine learning algorithm is going to take us 5 lines of code. Just 5 lines. The rest is dealing with the data. Yes, please.
So everything you're doing is data head, right? So you do data, only once you get the data label. What's the label?
No, it's the data label data label is a name of data. It's of a database. So I'm doing data something has.
I see.
Data label is also a database by itself. Correct. So out here. What I did here. So I did have information on when the claim started and when the claim ended. Machine. We have to be able to output important information for the machine to learn. So whenever we put timestamps, not even timestamps, but dates. That's this is the data set, right? Yeah, we have some date here, we have another date here. Now, imagine a machine that's going to look at every single date here and every single date here, and is going to try to find patterns. The machine doesn't understand that this is a day of the week or of the year. It doesn't understand like that. It understands just like a string, just like some text, just like any word. So what we have to do is to put this information first as timestamp. And it's going to become a date. The machine is going to understand that that is a date. But again, does it matter for a fraudulent or non-fraudulent operation or operation? The date doesn't matter.
There might be more frauds on Saturday.
It might be the case of a Saturday, but this means that we cannot use this raw information. We have to work with that. We have to, if it is a Saturday, we have to put another column saying Saturday or not. And put 1 or 0. So in our case, what we're doing here is I'm going to get rid of those 2 columns. And I'm going to put here how long it took from the final date to the first date. So but that's 2009, April 18, 2009.
Oh, the same year.
Yes, it's the same. So this code does this. Okay. So this part here, it was a string when I first looked at it into that, and now I have to put this into date format. So this part puts this guy into date format. Delete this guy here, please. And this one as well.
What was that doing?
Sorry? What was the zero doing?
Yeah.
That's because I was looking into to see if it was a string or not. And then I just copy and paste and put it there. The zero over there, let me show you. I have to grab this and not. Okay, we're going to have to work a little bit on that. So let me put here x1 equals. I'm going to tell you what I'm doing here. Basically, you see an error. It is saying that str in time, argument 1, must be a string, not a series. Basically, what I did here was, but this is a series. And grabbing every single information of a column. So this is a whole column. And then putting the pattern. This guy only understands one string, one cell of the column. So I have to build a loop to go through every single right there and say, look, that's the date for everyone. How do I do that? I could build a for loop. I could do that for range lab. So this would look for every single cell here. But that's not the efficient way of doing that. There's one thing called miscomprehension. That's what we're going to do here. And this format that I'm going to put is more efficient than a for loop. Why? I don't know.
Wait.
Yes.
What does? But now I understand. When you had the zero item, you thought that would get the first item. That's what you wanted?
No. The zero item is because there was a cell here. Because whenever you try to do some, get, I'm going to make a transformation, but I need to understand how this date is here. I don't know if this date is already on timestamp or not, or date time or not. So what I did here was to put this with 0 and output this. And I said, all right, so it's strange. So what I'm going to do, I simply did this, and I create this guy, and I paste it here with the 0. The 0 is an index. So whenever I do this, Regression, what do you think is going to be on the output of this?
It's one column.
And this is called a series. On the pandas, a column is called a series. So that's what this guy complained. So he said, look, the first argument is not a string, it's actually a series. So what I have to do is You think this will run? Those who follow? Ah, I weren't expecting this. Okay, kind of like let me show you something. Okay, what I did here, this comprehension. So for every single X in my series, I'm going to make this daytime dot time. Okay. So I'm changing that series. I'm creating a list of timestamps of daytime instead of having a string of a list of strings. Here we are good. However, I try to do the difference between one and the other. So my goal is to get the delta. I couldn't. Now let me show you this. Delta and date. Okay, so we have a list now of the date times, correct? If I do this 0, I have the first one, correct? This works. Six days. Because it doesn't have years. All right, so it works. What this means is that, again, I'm going to have to go through every single position and build another list with every single position.
But is it because it's like a date format? Because like what would it be?
Yes. That was my expectation as well. So now I have to do that. Joe, what is up? Okay, what I'm doing here is
The next line.
Next line is.
the next line is also. Is this going to work? I'm going to tell you soon. Correct. Yeah, so that's the data scientist law. You're going to make mistakes, you're going to put a play and it doesn't work, and it doesn't work, and it doesn't work. You figure out, but why? Because the line that is what's wrong is still there.
So the conclusion is data scientists have to be really good in tangents.
You do. Yeah. You do. And no, remember that I haven't used Google. It's because I've Googled that a lot. Usually it's because you forget something, you have to put something. What I did here, this is a major thing. Now this is an important, very important thing. But what I did here was I grabbed every single X and Y. So X is going to be related to the first one, and Y is going to be related to the second one. Here, I just have one series, correct? How do I do this comprehension in several series? I put this in, and between parentheses.
The zip, what does zip do? It makes a tuple, doesn't it?
Zip makes a tuple.
Right.
Yes. So it makes a tuple, and then it understands that this is a tuple, and goes line by line, and it's going to understand that and writing the first one, the second one, and doing some operation here. In our case, we are getting the base. The difference of timestamps and then the base.
So the tuple is that these in X and Y in
X and Y is going to be the date for the X is going to be the date for date M, and Y is going to be this.
When you have pandas read the CSV file, is there any way to give it a hint of the data types?
Can. Yes, that's a very good. Come here. It was a little bit unfair whenever I was talking about pandas because it's, remember that I put it as SAP equals a semicolon, one of the parameters that I could parse into. So basically, that's and you see, it's not like SQL. SQL is much better. The documentation. Now, this is called documentation. This is the documentation of pandas. Now, it has every single information, and at some point,
That be IO tools
sorry,
in user guide, IO.
CSV files.
I think somewhere you can pass in the names of columns that should be written.
But that's the thing that I'm looking here. At the documentation, it shows every single thing that you can parse in whenever you're reading a data set. Or, for example, sklearn, whenever you're going to read the objects for machine learning, you can parse hyperparameters. There's a lot of things that you can parse in. Now, where you can find all the information that you're going to be able to parse in. So that's on the documentation. And at some point, and that's what I'm looking. So here, for example, I could parse header, saying if the database has a header or not. Names, index column. So if I don't want 0, 1, 2, 3 as indexes, I want a given column as indexes, I can parse that in as well. Use call. Because the subset of the columns. There's detail. Inside.
Z-type, there it is.
So here I can parse the type of every single column. I can make that. But the timestamp is a different one.
What's the question?
If I cannot parse at pandas, I already parse the type of that column. Instead of doing that to get
So D types gives you the type in the column, and so are you trying to exclude columns when you read it in? What is the?
So the question is there a way to parse at pandas if a given column is a timestamp or not? So yes, you can do that.
Yeah,
That's
usually
the
you do it
answer.
in the second step.
No, pandas, whenever you read, it infers the data types. Yes, please.
I usually don't like to modify data as it's coming in because then it might damage data. Data is natively CSV text, human readable, and converting it to dates and touch problems that you bring data in. So you might as well bring it in text, then convert it purposefully to dates, and then subtract dates.
That's a very good point because whenever the correct way of doing that is to go through every single column and assess every single column. So you're going to have, for example, if you have an ace, I don't know how this would deal with the timestamp. if I were to parse initially already. Or if I, for some reason, I have some string here that is not a timestamp, timestamp format, it's going to break. So
Would it
yes,
break or just think it's missing?
I think it's going to break if you have some words. So a given word, it's going to I'm not sure, but that probably would. But yes, you will look into every single column and assess every single column. Let's move forward. Well, we got what we wanted. We have a column called days now. So what I did here was, okay, I grabbed another, coming back because we spent a lot of time on this, we have four databases that we want to put together. Okay? So we just did the first one, which is data in patients. And now we are going for the second one, which is beneficiary. This database has all the information of the person, gender, race, where this person lives, etc. What I did here was to drop one of the columns that had a lot of NAs, and then I merge the data that I had with the new database. How I did that? Why I put it inner. Inner means that if there is, so I'm using this key called Benny ID, which is the beneficiary ID, the person type. So if I don't have the information, gender, etc., this information of a given beneficiary, I'm going to drop that row. That's what inner means. I'm only going to grab information that has a beneficiary ID in both sides. Okay? Just to have a very clean database. And later, we can work on how to look at that. And I created the shape of the data. That's before we had 40,474 rows. And we continue having that. So every single guy here had an information here, but not the opposite. Moving forward, now I'm putting the data label. Remember that data label is our label, the thing that we want to predict, potential frauds. And now finally we have our final data. Yes.
Is it always the aim to denormalize the rows and duplicate the data across? Doesn't that cause a lot of storage and memory, and it would be better to have a data generator that pulls data in as needed?
Yes.
Because here you're duplicating all the beneficiary columns every single row.
Definitely, yes. But this is a 75 megabyte data. So. Okay, now the class is going to start. Okay, so this was very good for showing how hard it is to get the data, cleaning the data, and we haven't done much, to be very honest. We just merged the data together, and we've transformed only one column. Yes. Two columns to one. So that's why usually we say that it takes it's a long time for us to clean the data, to put the data together, and then to build a machine learning. The machine learning part is quick. It's not that hard. The last thing we have to figure out is NAs. Machine learning doesn't deal well with NAs. So let's figure out the columns that has a lot of Sorry?
The NAs are the non.
No, sorry. The NAs are non-information. So it's like you have a data set with a bunch of holes. These holes, they're not very good for the. Yeah. So, don't know whether I did. X. I'm not sure if this was wrong. Red, which is very good. But it's not exactly what I want. Good news. Good news. What I did here was, for every single column in my data set, I'm grabbing that series, remember, the series, and check if there's any NA there or not. So this is going to output a series of true and false, if a given row is an NA or not. When I put sum, this understands that the sum of a false and a true value is 1. So I'm going to sum when it transforms true to 1 and false to 0. When I sum it, it shows all the NAs that exists in a given column. So in our case, we are going to have 112 in our fifth column. Okay, so we have 112 in attending physician. We have in our database we have 45,000 rows. 112 of those rows have NA in attending physician. Now in this case here, we have 2 columns here that has a lot of NAs. Now I ask you one thing. Should I drop the columns? Now it's a question of how to clean these data sets. NAs you can replace, you can tackle NAs with a lot of different ways. You could simply put some average or substitute by some value. Now this needs a whole procedure of understanding that column, or you can drop the column, or you can drop the rows that has an A. Now I ask you, this case here, if I'm only thinking about dropping, should I drop this column or should I drop the rows that has this NAs?
Drop the rows.
The rows, because I have 112. It's not a lot, not at all. And what about these cases here? I have to drop the columns. Because if I lose, I'm losing a lot of information. A lot of information. Remember that rows are the information that I need to actually grab the patterns. So what I'm going to do here is to find out the columns, these 2 columns, and this, and then I'm going to drop all the rows that has an A after I drop these columns.
They're categorical. You can just set it to another value.
So I could, yes. So that's I could fill in for another value, but I won't have to access every single column. And at this point, at the first model version, usually I don't do that. I just want to put something out there so I can understand a little bit about the business problem. Okay? Can someone tell me how can I do that?
So check the pipeline documentation site because I've been looking for a way to do this faster. And so you could put a pipeline together that will do one-time coding, whatever transformation you want. You'll just run it. You'll just keep repeating it. It's kind of like the apply command. But it's a pipeline, like you did before with your class.
No,
Except
I
you
know.
can do the column
Yes.
transform. use the
Yes, but in
column.
this case here, how can I find the columns and drop the columns that I want?
So usually what I do is, same thing you did, is in some constructor, and then it'll give you a count of the what's missing, right? Not a number. And then you have to decide. You can call the computer and put a mean in there. If that's what you want to do. You can also, in the column transformer, if you're going to do one hot encoding dummy variables, then you can call it, and it'll just do it. If you have numeric variables, and you want to do PCA, whatever you want to do, you can just call it, and it's not going to think about what those columns are. It's it's a black box, just transform everything. It's a number or it's a category. So I recommend also looking at your data to see what's what. But I usually try and do it quickly. Look for missing.
It's more of a practical question here. Okay. Regarding finding the columns that I want to drop or not. That was the idea. That wasn't very good. Why didn't that work?
Just do what you did before.
So this is right here.
Are you just trying to find the number missing? Yeah, just do the thing you did.
But I want to print the columns that are in the exact position
Right.
of the.
Oh, you want the index.
I can simply do count.
Or,
You want to know I think it's if at or something like that. Okay, thank you.
Yeah.
Something like that.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 5.
Actually, you need to set up a bool, right? You need to set up a mask
Oh.
where the thing is equal to 0, and that will be true. And those are the columns that you want to.
Nice.
Right, so you want to set up a mask, right? So that it's just a bool, right? That says whatever is true is 1, whatever is not true is 0. That'll identify the column index, and then you're gonna drop axis equal to whatever that thing is. I don't know the exact syntax to do that, but that's a good idea. You have to decide, if it's 100% missing, then sure. Or it's not a number.
Oh, so in procedure, those two guys here are the.
So pass your statement into
Is that correct?
Yeah, pass your statement into a name and then call that name and create a mask on it. Right. So that you have a data frame that has in order the counts missing data. And if that is greater than 0, then you want it to be true. And then you're going to filter that data set, get rid of it, axis equal to 1, something like that. Yeah, so filter, you don't use the word filter. You have to put it with the right. Let me look.
Okay. Yes, those were the two columns that were the main point here. Now we just have these rows that we have to get rid of.
Easier than that. Yeah, so,
Okay, that's done.
yeah, do it, make sure you have in place equals true. And create a threshold, like,
Here,
yeah.
put in place equals true right here.
Yeah, so, like df dot drop in a, paren, yeah, say your threshold is equal to the length of the data frame times, 0.2, so if it's, 20% of that data frame, right? So if it's equal to that, then, drop in a, threshold equal to threshold, comma, axis equal to line, comma, in
That's
place
too
equal to
complicated.
true. Yeah, I would cut and paste and send it to you.
Now,
Oh,
this
it's
data here, now we've dropped the whole NAs and all. We have a data set that is clean, that is ready for us to start building our machine learning algorithm.
What's 39?
It was a final
Oh, the 39 is column.
number of columns, number of
Columns,
rows.
right.
Correct?
Number of rows.
Okay, well, we have 4 minutes. So stick with it. Now, we can see all the importance, guys. Okay, try to rush here. Look, whenever I'm in doubt of how to actually work with something simply, now you're going to see a beautiful thing. Now you're going to understand why a scalar is fantastic. We grab like this, just copy this. Now you're simply looking Google scalar and that's it. Oh, that's a different thing. You have all the parameters that you want. You have every single thing organized. And you have examples of how to do it. So that's much better. But actually before that, I want to guys, I think that it's going to be a little bit tired. Who here is waiting to stay? Who here has to leave? Who here has to leave? Can we do more?
How long?
Not 20 minutes. What do you think?
Good.
Yeah?
Yes.
Yes,
In
please.
reality, how fast can a machine pick up fraudulent patterns?
It's going to depend on the size of the database, and we are going to try to figure out this right now. That's why I need I don't know, 20 minutes. I think that we're going to
It's
start.
You're always looking for fraudulent.
What we are doing here is to build the algorithm. Once the algorithm is built, now it's just a matter of making predictions in this case. So what this class is to show how to build the algorithm. That's the idea here. All right, so we do have a bunch of columns. Now, we would have to go through every single column and work with those. So basically, what I'm saying is we have continuous variables. We have, I don't know if we have text variables, we have to check that. And we have categorical variables. I think we discussed these categorical variables last class, so I'm not going to enter here, but we have to get into create dummies for those categorical variables. What I would feel most comfortable for us to live with some sort of a good model here is to drop a few columns and then work with 10 columns. It's going to be a lot. What do you think? Yes? Okay. So let's focus. Well, those guys here, they are going to be dropped anyway. So the IDs, they are going to be dropped. Why? Because they are not going to be used to capture patterns. It doesn't matter the ID itself. what matters are the characteristics. So those were only used for merging the databases together. So those guys here, those three columns, first provider, then ID, and claim ID, we're going to drop. Insurance claim reimbursed. Do you think that's important? The amount of value? Yes. Attending physician, that's a categorical variable. Do you think this would be important? As well. The first diagnostic code, I would say so. Deductible amount paid. Probably this is going to be related to this insurance claim reimbursed, right? So we're going to drop this as well. So we're going to keep this guy, this guy, this guy. So let's drop this diagnostic group code. I would grab those two first here, so we can have some information on the diagnostic. So that's the admission diagnostic code, and that's the diagnostics group code. So that's probably the second diagnostics information. Probably the front-end things are going to be in between those two things here. This guy admits, and he actually puts something, and this guy is going to have a whole bunch of different things. I don't know. Dates, do you think is this important? Now, gender, race, some characteristics of the person. Those guys I can see if you put something on. I would grab gender. Do you think we should grab gender or race for assessing fraudulent information?
Yeah, because they might do like more
Watch out.
fraud for certain. Oh.
Say some next question. No, but that's definitely, unfortunately, that's the we do have some. We have research on that. But it's not about the gender itself. It's about the thing that gender or race captures. That's what's the it's a co-occurrence. Could be something related to co-occurrence. You have another variable that actually is the cause, but it's for some reason it's wrapped by gender or race or something. No, it's not a covariant. It's something that. But it's let's say probably income is going to be something that would enter here. But you're going to see, at least in Brazil, not like I can say, that you're going to have a hyperrelation between race and income, which is a very sad thing, and we are working on that, but that's not the case. So if you put race, you're going to get some information that you would say, oh no, this race is actually has more frauds within this race, but that's not the actual variable that renders more fraud. So I'm going to grab those guys, and probably those guys, they are safely use those because they are categorical variables.
If there are errors made in the deductible, could you eliminate them?
I did, and it might be the case. So combine and going to and now I had to do it because I was already run this. Or remember, that's the first ugly version of the model. Okay, so now I'm going to close. So I only have. Okay, that's good because I have attending physician. Let's see here. The attending physician. Let's see how many attending physicians. Let's see how many there are. Okay, so we have a data set of 45,000 rows, and we have 11,000 different attending physicians. Do you think that's good or bad for our situation here, for what we want to do? They are different attending physicians. So we have 45,000 rows, and so basically 1/4 is attending physicians are different. So you're going to have a probability of 25% of those. Might be the case. Might be the case. I'm very inclined here to talk this one. Yes. Yes, because I want to grab patterns. And there's a pretty good chance that I don't have enough sample to grab patterns from a given attending physician. But I have 11,000 attending physicians. So it's like I have 4 rows for every single attending physician, in average. That's not big enough. But she brought a very good point that it might be the case that they have, because they're going to appear anyways.
Maybe
There could be one attending physician who's like, of course, of course.
But this is. They call. What is the name of the problem? Potential function. Okay, so what I'm doing here is I'm filtering out the database where this is equal. Yes. Okay, so we have 4,000 attended physicians, different attended physicians that that transaction seems to be fraudulent. So I don't think that we're going to go over that. Yes, please.
Just a question quickly about the data. So the fraud is by the physician, like a Medicare,
I don't know. We don't know.
not the patient.
We don't know.
So what we're saying is, okay, it's in the Kaggle site number. Because you have to merge the provider IDs to your transaction claim statement. Keep going, sorry.
Well, for the sake of this, the SMS here, we're going to drop this one and I think that we should have it. Yes, definitely. But that's the point. It's good. This is going to take a while, and we should check. Remember the descriptive statistics that we did last time. We should do that for every single column. The whole data set and most of the combination. So this is going to take this is what takes the long time.
And where are they that? Because there aren't enough of them.
We don't have enough rows to 4. Yes, it will be an average of 4 rows for attending physician. So this is not enough for us to grab the pattern of that attending physician. 4 rows is not a lot. That's what we need. Be required. So I'm not going to say that you need at least 30. Not going to say that. That's a rule based. That's a econometrics of the streets. It's not correct. I haven't. So we do have potential drugs. See that I've made this mistake a few times already. Okay, so we're dropped. All right. Now we don't have any NAs. Not yes.
Sorry.
I always forget this comma x is equals 1. What does this do? If I just put that drop, it's going to drop rows. If I put x is equals 1, drop columns. So he's looking at the rows where the indexes is still attending position. That's why it's breaking, because my index is there.
So if you had wanted to drop just the first row of that column, you would have put the brackets in 0, right? And then
No, I would have to find the index, which in this case would be 0. But I would have to find the index of this cell that you're seeing.
and that's it.
Yes.
So it's the provider ID where the fraud, yes, no, right? Potential fraud.
Yes.
And the provider is probably a hospital, not the attending physician at the hospital. So I'm not quite sure what you're doing, but they're looking at Medicare claim. I'm on the site now looking at it. So there's about 9% of that total provider ID file, which means 9% of the hospitals or wherever the care centers have this potential fraud. So you still have the same problem that you mentioned about low prevalence, but you get more data than what you're saying here. Unless you're saying the attending physician, maybe it's the same physician, and also sometimes the attending physician ID is just as fucking MPI, and just all scripts or whatever, just get moved to that ID. So you don't have enough unique IDs to identify.
They don't have the unique IDs to identify either the hospitals or the clinic physician.
Yeah, I think hospital is your unit of analysis here.
Okay, now let's go to quickly to usually when I'm trying to see if a given code is going to run without going to Google, I think that is going to run. I do a test. Usually I put test, but the important is test. Equals data dot get did not get dummies. Did it work? All right. Well, let me show you this. Just to show you. Okay.
What does the get dummies do?
That's the. Guys, we're going to stay here until 10:30.
No, we're not.
But everybody's here, so everybody's liking it. Get dummies does this. Gender. Male or female. Right? So this is one column. Now, machine learning algorithms doesn't like that. It needs to look into numbers. So what get dummies do is to put male as a column and female as a column and 0 or 1 if it is a male or female. Okay? So that's quickly speaking, that's it.
It knows what columns to do that with?
Sorry?
How does it know what columns to do that with?
He understands what are the categorical variables,
I know.
categorical items. He understands the continuous variables
Hmm.
that are there, and he makes this transformation. And this is what I would like to show you. We had 27 columns beforehand, and now we do have almost 5,000 columns. Because every single category became a column.
Does it also drop one because of coding already?
I didn't know that. What's it?
I'm not coding here. Second columns. Because they're
This one, if I'm not mistaken, this is won't drop the columns. Let me show you this. No. Okay, so the get done in this case, it renders. Yes, so look, every single diagnostic code became a column. I'm almost sure that at this stage it doesn't hide one column. This is going to probably hide. This is going to run into problems whenever we try to do the machine learning algorithms. We have to highlight the columns ourselves.
So any column that's not numerical is going to do that. Is that right? Any column, not numerical.
Yes. Which is terrible. So that's and why is this an issue? Because now we have 45,000 rows, but we do have 5,000 columns. So we lose a little bit of the pairs there. It's not very
The
good.
code's on, so.
Is that another reason you dropped the provider code?
No, if I put every single code there,
Yeah,
there are
it's just that
other
it's
columns that I
because-
simply drop.
You must be.
And usually this forces me to drop more columns, but well, that's the key part of the data science. We have this diagnostic code, 0059, 00845. Probably this code here is too different from this one. Usually on codes, you have 2 digits, 4 digits, 6 digits, 8 digits. Usually, I'm not sure if that's the case. But what I would look in this case, I would look into try to aggregate this into lower digits. Then I would have less codes. Okay. I'm going to continue here. The model is going to be terrible, but just for us to go through every single thing, and then we continue this next class. Okay. And actually, of course, you also have this code, so you can go home and you can do the next class.
The updated code. Yeah,
Sorry?
the updated code.
It's the same link that you have before. Let me save it. Okay, so all right. Now we do have the half encoding, everything is numerical. No NAs. We have to make this here, that's it. Now let's go to the learning part. So the first thing that I'm going to do, and that's how machine learns. We are going to we have a whole data set. What we're going to do is to split this data set into a training data set and into a test data set. This test data set we're going to hide. We're going to use later. The training data set is where we are going to teach. We're going to use to teach the machine. What we're going to use to teach the machine. Okay? Let me show you this. So if you come here to the description, blah, 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 blah. I call this TTS. Remember that I imported here, so I'm going to the sklearn package model selection. I'm importing this guy, and I'm calling this guy as split as TTS. So TTS. That's the new thing. Okay. The same thing. I don't know why they just don't change from the default to the graphic. It would make my life easier. Right, good news. What we did here, so we had a whole data set, and now I said, look, I want to predict potential fraud. So I'm going to call this Y. And my X is all the characteristics of that case. So I drop the potential fraud. Now, when I'm going to split between training set and test set. How I'm going to split this, I put the data sets here, and I said, look, 30% of the data I'm going to use as my test. I'm going to diminish this a little bit to 20%. This random state is just a number that we put to be able to replicate the same split again and again. That's not important. All right, so now we do have, out of the 45,000 rows that we have, more or less 31,000 rows are going to be used for training the model. Okay? All right, so we do have the training set, my Y, X. Now let's do this. So let's only do the decision tree today. So again, let me put this here. Let me Google it. All right. Beautiful documentation. Right. And the pattern is the same. So every single algorithm has the same documentation, the same pattern. So you need to understand everything. That's why Python is so famous, because of the documentation and the convenience. If you put something on Google, someone has asked that question before and someone has answered that before. So basically it's just like you spend your whole day Googling it. Right. Now remember the hyperparameters that I told that every single object has. So we can select every single thing here. We can tweak. So after we deal with the database, the 80%, after we train our first model, the rest of the time is changing those guys here to find the best way to make the best algorithm. But let's, I promised you to have 5 lines of code, right? So this. What is this guy? So I've created now one object called decision tree classifier. Also, every single object has some information, some what you call these methods and attributes, some characteristics that you can change, you can work with. What I'm going to do is to fit parentheses. When I do this, not perfect. So we still have one string. What is this? Our data set's not.
So it's a clean data diagnosis code. It's like mine.
Really? Diagnostic scope?
Yeah, clean diagnosis code.
Wait, haven't we dropped that? We dropped now, but we have to put it into guns. Do that. There are some of the columns are still not.